Hello and welcome to this lecture in SQL Introduction, and we'll go into the theory about the introduction to SQL and using DB in SQL. This is an introductory lecture in this course, SQL Analytics with DB. You will learn a lot about how to use DB to turn messy data into valuable insights. That is the main topic for this course. And later on in this course, we will also connect to Python so that you can work with DuckDB within the Python ecosystem and within the data science, data engineering, data analytics ecosystem. This is really fun, and we'll go directly to the slides to get an introduction to what SQL is. Turning data into valuable insights using SQL. We start with an example. An ice cream startup, Swedish Glassiker, is using Excel sheets to store data. This might be a viable solution. In the beginning, you just store the data in Excel sheets. We have orders, we store them in Excel sheets. We have customers, we store them in Excel sheets. We have inventory, we store them in Excel sheets. Okay, it sounds quite simple, and yeah, we can start like this. It's no problem in the beginning, but the company grew. This was really a classic. Like, people really like this ice cream. They ordered a lot and we got a lot of customers. And then when we did that, we needed to employ more people. The thing is, we have a team now. Each Excel file is shared across the team. We have orders, we have customers, we have inventory when the business is growing. But let's simplify it to this. We have one person that is working with this. We have another one that is working with this. We have a third one that is working with this, and a fourth one. If there's a lot of people working with these Excel sheets and we get a lot of data, then it's quite easy to get duplicates, for example. Common problems that arose when sharing Excel sheets in this way: we get data duplication, accidentally creating duplicates without knowing that these lines may have existed elsewhere. And that is the problem, that we need to manually update in several places. And we get inconsistent data. For example, we look for one person and then suddenly there is a similar person with different addresses, or same person with different addresses. Then we have an inconsistency in addresses, for example. One is a typo, another one is not. We have relationships. It's hard to manage manually between customers and orders. Which customer connects to which orders? That is hard to manage manually. Team, they manually links the order to the right customer. This takes a lot of time and it's manual effort, and it will lead to inconsistencies and bugs. Like you do errors because human is not good at manual work. Performance. Our Excel sheet is growing larger and larger, and this will cause performance issues. It will get slow to work with huge amounts of data in Excel. And many more problems that we won't go into in this slide here. The idea is that we need something else to manage this when our company is growing. An example of inconsistent data, you can see it here due to manual input. For example, here you have Alice Frost, alice@example.com, and this address. And then you have Alice F, Alice_F@example.com. Okay, it seems to be the same person, the same phone number, same address. But here we have Alice F, here we have Alice Frost. Here we have Alice_F@example. Here we have Alice@example. Is it the same person or not? That is a question. Is this the same person? This is, and also we'll come back more into how to handle inconsistent data and how to make sure that the data is unique and what is determining a unique row, etc. This will come back more into a data modeling course later on. However, for this course, we will focus a lot in SQL queries and how to analyze the data. This is due to being able to both learn the fundamentals in SQL and to work with it with analytics and for transactional later on. And also we will learn it that you can go, for example, towards data warehouses. And you do need to understand how to analyze the data. But that was a side note of what I just said. Now, which is linked to what orders in the orders table? Using relational databases and SQL, we can handle many of these issues. SQL is a structured query language, and the database is a relational database. There are also non-relational databases, such as a document database, vector database, etc. And no SQL, but here we have relational databases and SQL. They follow something called the relational model that will come back later on as well. Define relationships in SQL tables. This ensures data consistency. They are optimized for large volumes of data, scalable and efficient for querying of data. Data constraints like data types and unique values are put in. Make sure that the data conforms to a specific type. For example, you have a numeric column, then you cannot put in strings or other types of data. And you have unique values. You can make unique constraints. This makes sure that we get automatic validation, which reduces error. I talk about this type of thing. This part is more concerned with something called OLTP that we'll come back to, more transactional databases. And there's a lot of nice benefits with a database. SQL, what is this? What is SQL? It's structured query language. We have create, update, and we organize data into tables. Okay, tables, we have rows and columns. You can see it as similar to the Excel sheets. You have rows and columns, right? And SQL, we have standardized language. Is standardized. There is a lot of different flavors of SQL, but mostly it's similar. And there's some syntax that differs, but the foundation is the same. It's based on a relational model, and what this means is that we organize data into related tables. We link the data through unique identifiers. If you don't understand what this means right now, it's fine, and we'll come back to this terminology later on. There are some core functions within SQL. We get DDL, data definition language, define structure of database. For example, tables and what type of data it holds. We use create, alter, and drop, for example. We can create table, we can alter the table, we can drop tables. This is DDL, data definition language. Moving on, we have data manipulation language, DML. These are to manipulate data directly in the database. We have insert command, we have update command, we have delete command. And then we have DQL, data query language. It's to select, you use select statement to retrieve specific information from a database, letting users access and filter data for insights. We use the select statement or the select class. We'll see we'll use it a lot in this course to analyze the data. And we use it together with a lot of other things to filter, for example, the where class, the group by, etc. And then we have DCL, data control language. We have here you can revoke and grant to give access to other users. You may want to give access to certain users for a certain type, certain database or certain tables, right? Depending on which SQL you use, there's a possibility for more or less DCL. Yes. And then we go into the SQL flavor that we will use in this course. We'll use DuckDB. Meet DuckDB, a modern, powerful database management system for analytics. It's super powerful. It's super performant. It's optimized for intensive analytical queries that you can do locally in your own computer, and it's very easy to set up. You just use a DB file, and then you can connect to it in the terminals. And also, we talked about the OLAP, then we need to mention OLTP, which is for transactional database. That is optimized for a lot of inserts into the database. For example, other RDMS such as Postgres, Microsoft, they use, and they are right, while is OLAP. It's very highly performant on your own machine and can handle large datasets. It's embedded database, no need for separate server, and database is contained in a file. This makes it very simple to work with and very good to start with as a first course within analytics, to just learn how to get insights from the data, to filter the data, to manipulate it in the way that you want. And it integrates very well with other tools in the data science ecosystem or data engineering and data analytics ecosystem, such as Python, Pandas, and data frames. We will work with it together with Pandas in this course so that you can see the power of combining Python and DB in order to get data insights that you want. Very good for data analysis, can run complex queries for analytics and reporting. And it's very good for building data transformations in an ETL pipeline to serve business intelligence and AI. We'll come back in more, if you follow me, I have courses in data engineering, a lot of them. And then there I usually build ETL or ELT pipelines to be more specific. And there DuckDB is a core part, could be a core part of it where you store the data. You could use DuckDB as the data warehouse, for example. A data engineering pipeline with an OLAP database as a data warehouse. The reason why I picked data engineering pipeline is that when you're working with data analytics, you usually have the data, you want the data to go through different types of transformations. Here is data engineering pipeline, and we use, for example, DuckDB as the data warehouse, but you could use something else, such as Snowflake, Amazon Redshift, or Google BigQuery, but could work for a local solution. What you have is that you have different data sources. This could be like CSV files, APIs, you could have other types of data. And they are ingested into a data warehouse. The data warehouse could be this DuckDB file, for example. And then you serve dashboard. You serve machine learning models. Then you need to transform the data in certain formats. They can be served downstream applications. Here you have ELT, extract and load. You extract and load the data into your data warehouse. Then you transform it inside your data warehouse. And then you serve the data for the end users, the dashboards and the ML models. Here, for example, other people can take over. For example, the BI analyst could take over. Here could be like a machine learning engineer or a data scientist that take over and take the data from the data warehouse. DuckDB, it could work as a lightweight data warehouse for small to medium-sized data. And if you grow out of your DuckDB database, it means that you cannot do it locally anymore. Then you can consider cloud solutions, but they cost money. Okay? Yes. That was an introduction to SQL and DuckDB and kind of introduction to this course as well, but we will have more introductions such as the course structure that you can see. What is the actual content of this course and who this is suitable for? I hope that you have learned some basic concepts about the motivation, about why to use SQL and databases, and then also going into DuckDB and some motivation about that. And stay tuned for more videos where we'll actually go into coding and more practical development and analyzing of data. And that will be really fun. I hope to see you there. And thanks for watching this video and see you in the next one.